This is 𝙎𝙤𝙘𝙠 with Gruber Power here in Superior, Arizona at the Queen Creek Tunnel. This is the lighting control system for the entire tunnel. We are replacing batteries on this unit, and then when we get done with the batteries, we're going to troubleshoot the unit because it may have some issues there as well. Most batteries have their torque specifications right on it. Right there, 32 inch-pounds. You need a torque wrench for that. The way these things work, you pull off the handle. I don't know if you can see this, but pull this down and you can actually turn it and get it to go up and down. I've already got it set for 32, and so you want to get it right at 32. Once you got at 32, this is a very delicate job. You don't have, there's no muscle involved at all. All right, all batteries are in. The only thing we haven't done is put the interconnections on. This is our charger coming in. That's why everything's jumper, and there's two. This is one string. These two rows down here is the other string. So we got string 1, string 2, string 1, string 2. That's why these are jumpered together. So this is all live here. These are live. Everything going in here is live. But is a UPS live? Nothing. So I cannot, if I turn these on, I blow up the UPS. Because remember your flow of power. If you try to feed that inverter without having any voltage on the inverter, you could blow out the capacitors. All right, batteries are in. Next thing we're going to do is we're going to use is called a Uminterruptible meter. It tests the conductance of our battery and how well they are. And we're going to test all the batteries just to make sure that the factory gave us good batteries here. We're going to do 36 of them. So right now it counts up 36. It wants to know the temperature reading, so I just put it in here. It says it's 74 degrees in there. Got good temperature. And the next thing that happens is take your, we're going to start from the most positive. Most positive would be battery number 1. And we're basically going to just follow this, most positive right there. We're just going to follow this all the way down. Now what it does is it gives us a reading right here. It gives us the voltage, 12.8 volts, which is fine because the batteries have been sitting for a while, 73 degrees, and our conductance is 1122. So they should all be right around 1122 plus or minus 100. All right, now we just go right down the line. What you're going to do is make sure that you always have the red on the positive side of the battery. The light turns off when it's got a good connection. Now see, it crosses over here, so we're just going to cross over with it. Now we just do this. A lot of times it doesn't cross over like this. It's just that this one's a little different. What my meter is alarming on, it's alarming on the voltage is a little low. Like that one, it did a single beep. That means that the voltage was fine. But we're right at the lower threshold just because the batteries are, they haven't been charged or anything. Or I should say top charged. They got a good voltage on it, 12.8, but a dead-on perfect voltage for any battery is 13.5. Whether it be a car battery or UPS battery, it doesn't matter. They're all 13.5 volts is a perfectly charged battery. And what it is it's just throwing out the conductance on the battery. Right now it's throwing out 1122. So what we're going to do is we're going to take all the numbers that it's throwing out at us. Like this battery here. What's this battery at?
1236.
So this is 1236. So see, they're not all the same exactly. But what we're going to do is we're going to take the average of all 36 batteries. Was it 36? We're going to take the average of it. And that'll be our conductance level. After about 3 months, we're going to come back and we're going to check the batteries. And that number that we get will be the number that stays with the battery until the batteries die. So over time, that 1200 will go to 1100. And then from 1100, it'll go to 1000. Until basically, you got nothing and you got dead battery. And you just do it all the way to the last battery. All right, batteries are tested, and tonight I'll figure out what the reference should be and figure out the average. But now we need to figure out this UPS without shutting down all the lights off in the tunnel. The customer wanted us to troubleshoot their UPS. Their batteries basically melted down, and we got them replaced. And the next thing we need to do is, this UPS is not putting any output out right now. So we need to figure out, I don't believe there's anything wrong with it, but we just need to get permission with the customer to make sure we can do some troubleshooting with it and try to figure out what's wrong with it, because the whole objective is this little green line right here that goes to the top. We want this green line down here going into your rectifier or charger, going down in here to the batteries. Let me get back where I was. Going back into the batteries, and then going back up here to your inverter and out to the load. No green light at the top. So we want it straight through. That's our goal. Alright, so we got the DC fuses. We pulled them out. What we're doing, I'm just waiting. I just want to hear that tone from the meter here. A solid tone means I'm making a good connection and the battery or the fuse is not blown. So we're going to leave that the way it is. Like I tell everybody that I train, is know your flow of power. So we got this lid open. My flow of power tells me I should be able to turn this on. And what I've got here is my input's on, my static bypass is on, but my maintenance is off, but my output is on. So that tells me I should be able to throw this breaker on and this one off. And that is not correct. It'll trip the breaker. So they really have, so the next step is that we're going to shut down the tunnel. Clean. The lights off in the tunnel. That one's good. Good. No tone. No tone. No tone. We got 3 bad fuses. Let's replace those fuses and start her up. All right, so we're trying to turn it back on during a troubleshooting process. UPS says that it has a bypass. No bypass available. Normally, we see that a lot on UPS, especially when we look at the logs. So I didn't think too much of it. But what we have here is we have these 3 fuses right here are blown. And as you saw earlier, how we test them to make sure whether they're good or bad. So long story short, batteries are in, batteries are ready. UPS, not so much. Replace the fuses. Let's go into there and test that. The next thing we got is what I did do is I did turn this on. This is their maintenance bypass. I know why it tripped before is because we have a bypass problem over here. That's why it was tripping. So we've got these off. These are on. UPS is off. We will come back at a later date and replace these fuses and place everything back online.